Hey everybody, today we'll do another video. And today we will do another, it's going to be a quick problem. Um, so we will continue to work in circuits. Um, and we will continue to use the technique that we have been learning in the past. How to solve problems, right? So basically, that is the whole idea of doing this, building it up, right? So in the case of, I have a circuit and the problem says that the problem says that A it says a sinusoidal source sinusoidal source right, sinusoidal source actually sinusoidal. Okay, so produces an effective voltage of an effective voltage of 100 volts, right? Um, and it says the source contain internal impedance of, right? The source contain an internal impedance of 4 ohms minus 20 J, right? Connected to a 6 ohms 6 ohms load, right? So now they have a circuit. So circuits like this. So we have a source, right? This is 100 volts. And then we have a resistor, of 4 ohms. And we have a capacitor, right? Of course, it's capacitor. If you see the negative, that's capacitor. This capacitor is negative negative 20J, right? And then it goes like this. It goes like that. And then we have a 6 ohms load, right? So notice that everything is in series, right? So here everything is in series. Now, so they asking, the question is, most nearly the real power dissipated by the load consists of the resistance is, right? The question, the question says most nearly the real power dissipated, right? The real power dissipated, I think, right? The real power dissipated, right? I think that's double S on that. Yep. Dissipated by the load is, right? And then they give us some answers, right? So we will determine which one it is. Right? That's our job. Okay, so how will we handle this? First of all, it is a series circuit, so I need to find I total, right? Because it's a series circuit. And we know that in this case it's going to be the voltage source, the voltage S, right? Voltage source divided by some total impedance, right? So that is going to be the current. Now, so how we go about this? So we know that these two can be combined, right? It's the same thing. That is the only two that can be combined in the circuit, right? We cannot add that one. So we can say that 4 ohms, right? 4 ohms plus 6 ohms minus 20J, right? Which is equal to 10 minus J20, right? Now, remember the Z is going to be equal to the square root of that. So C total is going to be equal to 10 squared plus 20 squared, and we take the square root of that, right? So when we do that, we get that. So we get 20 square plus 10 square. Taking the square root of that. It's 22.4, right? So this is 22.4, right? Now, and this technically is on ohms, but we don't have to write that down. That's ohms, right? Now, so actually, good idea to write whatever, right? Ohms. Now we can find the current by saying that I is going to be equal to, and of course this has an angle on it, but we're not going to work that for now. But we taking the inverse tangent in this you will get an angle, right? But anyway, so the inverse tangent of this over this, that's what I'm trying to say. So remember, this is like y, this is x, and this is y, right? This is the real, this is the imaginary piece right here, right? So that's the part that corresponds to the imaginary, right? So with that being said, let's get this done real quick. Right. So we know that the impedance now, right? So now we say that the voltage 120, I'm sorry, 100 divided by 22.4, right? So when we do that, we get 100 divided by 22.4. It is equal to, you can say, 46. So it's going to be 4.46 amps, right? Now, so this is I total, right? Now we know that this current is going around the loop, right? It's going around the loop. Now, having that, this current has to go through here. You got to go through here, and then by the time it gets over here, it's the total current coming in back to the source. So what we can do is say that we can say the power, they asking for the real power, right? Real power. And we can actually do, I mean, you can complicate yourself in this. You can find the angle and then use the sine, 1/2 sine, and take the angle there, like it, you can use the power factor, right? Base the angle and then use the formula 1/2 is equal to IRMS times BRMS. The cosine of the angle, but that gets too complicated. We don't want to complicate too much, right? Things. So what we can do right here is that we can say the power is equal to what? Is equal to I squared, right? Which is this one times Z, right? So, but actually what we're looking for in this case is R 6 ohms, which is this guy. This is the guy we're looking for. We're looking for the power dissipated by this guy. So we say the power is going to be equal to 4.46 squared, right, times 6 ohms, right? And that is equal to times 6. So that is squared times 6. 120. This is equal to approximately 120 watts, right? So that's that. It's kind of easy. It just requires a little knowledge, right? To add those two, get the third resistance, right? Not bad at all, right? So now another problems that they want us to see if we can actually have some understand is the following. So in this case, they want us to they said They say an ideal transformer, an ideal transformer, an ideal transformer an ideal transformer. So, okay, so an ideal transformer okay, contains 100 turns in primary coil, right? In primary coil. Primary coil, right? And 400 turns in secondary coil, right? The impedance measured in the primary terminals or the transformer is, right, the impedance measured in the primary, so measure in the primary coil terminals, right? They say terminals. Terminal is 100 minus J50, right? Most nearly mean, right? The question is most nearly mean, right? Most nearly, right? Most nearly the impedance is in the secondary is, right? In the secondary circuit, right? In the secondary circuit. Secondary circuit is, right? So they asking us. So they give us the primary, right? So they give us the primary. They want us to find the secondary, right? They want us to find secondary, but they give it the primary, right? The primary terminals. So now, let's remember that A is equal to n1 over n2. Right. So this, actually, let's just copy lines. So n1 over n2. Right. Also we know that the C primary is equal to A squared C secondary. Okay, so now think about it. We have this guy, which is the primary, right? We have this, so we have the terms, right? So we can use this, we can use that, we can use this, and we can use this to solve the problem. Now, first, we need to find our A, right? So A is going to be 100, right? So 100 is the primary. So primary, secondary, so 100. And the secondary is 400, right? So A, right? Cancel that, cancel that, cancel that, cancel that, is equal to 1/4. So we have this. Now, look at this. So we have 1/4, right? So we have this A, right? Now, what we do is the following. So we have the primary, right? The Z, right? We have the impedance of the primary. So we replace this guy by this guy. And this is one of the things that you need to kind of, I don't know, but if you're taking a class, your teacher is not explaining a lot of this basic stuff that can be done using these formulas. It's very easy when somebody just starts talking, and then I'm explaining stuff and you get lost. But think about it. So they give us a term. Based on the terms, we found A, right? We found this ratio. We use this in this formula, right? And what are we trying to find? We're trying to find the secondary. So basically, we will replace this guy by this, right? So what we do is the following. So we do 100 minus 50, right? J is equal to what? Is equal to 1/4 square, right? And CS, right? We are going to solve for CS. So how we do that? So we write here, step by step, 100 minus J 50, right? That square is going to be equal to 1/4, 1/16, right? And then times the Z, right? C secondary. Now, let me just give myself a little runner here because I need some space, right? C secondary. Okay, actually no, just leave it like this. I do it in the next step by step. C secondary, right? What I will do is write this down again, and I will say 100 minus J 50, right, is equal to 1/16, right, times 16 over 1. See how fractions play a very important role in engineering. That's why it's very important to understand this when you're taking basic mathematics. So now you notice that I have a zero here, right? C secondary. Now, now, I do the same thing. If I flip this over here, I gotta flip it over here, right? So I do flip this over here, 16/1, right? And that is being multiplied, right? So this guy cancel out, right? Gone. And then what I can do is the following. So what I can do is the following. I can put parentheses around here. Multiplying that guy. When I multiply this times this is going to be equal to 1600, right? Multiply that times that is equal to 800 J 800, and that is equal to C secondary. And of course, they give us the answer, and that is the answer. The answer is C for this one. So that is how we solve these problems. These problems are not meant to be really, really hard. They just are meant to test out the knowledge. What is going on in the problem, right? What are we understanding the problem statement? Are we using the principles of basic circuits, right, in order to understand this, right? So another thing that you can actually find, and this is more experience, right? Because again, in school you don't learn a lot, right? Teachers don't normally teach this stuff. It just, a lot of this stuff is just, But as you can see right here, the secondary has more ratio, has a high number of coils, right? So what is this telling me? It's telling me that the secondary, this transformer is a step up transformer. This is going to be higher. This transformer is going to, it's just right here. The voltage over here is going to be lower than the voltage over here. And how you can prove this? Well, obviously, right? When you do the math, for example, in this case, the impedance of this, the current, right? So if you take some certain voltage, right, and divide it, but did you know that the impedance in secondary, right, is higher, right? And when you multiply this I times R, right, it's going to be higher voltage. The impedance increase. It went from 100 to 1600, and it went from 50 to 800, right? The current is going to be lower, but the voltage is going to be higher. So that's how, we analyze circuits and making sure that we are kind of understanding what is going on in the circuit. And thank you for watching. And remember that this is the Academy, Conservative Engineering Academy. We praise Jesus in this channel. So thank you for watching. I see you in the next video.